Hey, and welcome to Vivid Talks. Today I'm joined by fellow board member Todd DeCapua. When I first met him, he worked for Hewlett-Packard as a chief technology evangelist. And today we're going to be chatting about what he's been doing since and some of the new technologies that he's been working on. And, we're going to get into a bit of a debate on technology and the state of performance engineering. So yeah, I had a couple of thoughts around. Obviously, I've got my TED video in the background, which you've probably seen a few hundred times. And they're obviously working remotely in the video, which is quite interesting in the sense of the clip which comes up in a second, which is someone flying in the air. They're using a touchscreen augmented reality so interact with the kids playing a video game in the back, but then she takes over and she starts adding stuff to the shopping, right? And I've actually got a Tesla 3. It's sat in a warehouse in Birmingham. I'm waiting to get delivery for it, but with the Tesla, obviously you can drive as long as you keep on tapping the steering wheel every 3 minutes so it knows that you're there. And you could, in theory, order your groceries and stuff from your car. You wouldn't be able to do it at the moment with coronavirus because no app seems to work. But I think that was my first kind of discussion point. What I was finding is, so, I don't know what it is like over in the US, but we have a couple of major grocery shopping companies that we use, right? Now, the first one, which I know because a good friend of ours who you might have met, a guy called Paul Smith, he was the head of performance engineering for one of these companies, and used LoadRunner, right? I used to say to him, I said, how do you performance test it? And he said, with the website, what we do is we put values in for the most shopped items. So they were looking at the kind of shift right aspect, and they were looking at, what is the search getting entered? All right, what are the biggest hits? And in that case, it was interesting because the big hits were lingerie and technology, right? They were the two biggest searched items for this big retailer. So most of his scripts would go with, I'm going to say happy path, but the happy path journey through searching for, a new listing. It could be, let's call it an iOS, iPhone 12 or whatever the next one is, right? And obviously those searches were all cached. So part of it is they cached it based on that list of all the shopping items. And, his script would come back with, yeah, it's good, right? So they only had 12 scenarios that came through. One, searching for an object, something, adding it to the basket, the standard journeys. And I said to him, doesn't seem like a lot, 12 scripts. And, the fact that you're kind of happy pathing it with the 50% of the representative test data being lingerie or technology, what happens for the other 50% of groceries or the subcategories? It's not a full spread. So test data sets associated with giving you the data coverage, not just the the test coverage. Two big concerns there. And so taking that for a step further, that retailer shut down their mobile app. So we had it week one of isolation. They put something out to the press saying that we're currently queuing using the app and round robining the people so that they get access to it. So just keep with us. The day after, they turned around and said we're shutting the app off completely because it's not working. So everyone went to the website, which is fine. And then a day later, they put out a notification saying we're now shutting down the website due to high traffic and our infrastructure can't support it, right? So this company in essence just went out of business, right? In week one of this isolation. Now, a couple of weeks later, they came back, and the way that they solved it was shut the mobile app off and add a queuing app at the front of all the front of the website, right? And this queuing software, which is well known, and I won't name and shame them, what that does is it's got a little man walking along a pipe and says, you have 670,000 people in front of you. If you wait 8 hours and 20 minutes, you'll be able to access the website. And obviously, it's holding them there away from the DNS and then lets them in after waiting a profound amount of time. And I have sat in that queue because I've had to order some food, right? But what I found really interesting about this, not only did every single company who's a grocery company in the UK use that same queuing app software to put people in a virtual queue, but what I found really interesting is that their mobile apps failed, and they didn't just fail slightly, they failed catastrophically. And what I found interesting about that was their websites didn't fail as badly. And I don't know if that's because performance testing or performance engineering has focused on websites and the principles of load testing in comparison to mobile, right? And I've got I've got probably something which is incredibly politically not correct, and people may want to just delete this podcast once they hear it, but I don't think people performance test their mobile platform. Now, when I say this, what I mean is I'm going to do it next week, right? If I stick my phone between, so if I get my Raspberry Pi and I put Kali on, put Support Swagger in the middle, create a phony virtual Wi-Fi spot, connect my mobile phone, and then intercept all of the traffic. When I launch my phone and I capture that PCAP file with all the calls that it makes while it's launching that app, I've got a feeling that there's more to it than just an API endpoint on it and some kind of curl, right? I've got a feeling that, it still has some of the principles that you'd expect, like CDNs to take images down. You've got things like swipe to do the credit card transactions, for instance, right? So there's all sorts of different elements which I still think do create some traffic on there. Now, of course, we also know that the mobile app kind of comes pre-packaged with a lot of that stuff, so it doesn't download it's not as heavy. It's like a thick client in comparison to a thin client where people are downloading all the libraries on the web. And we also know that, to get through the approval process through Apple, you may find that to update that app, you may take a couple of hours, a couple of days, depending on how big of a change it is. So my question is, do people test mobile traffic, or do they just test the APIs and emulate mobile devices using network virtualizations, network function virtualization? So this is my kind of question. I know you've done this for large banks. What have you seen?
I guess, you've done network virtualization or network emulation. I was very much learned how to do that as a result of this Category clear. So, we had launched the first functional mobile application for banking in the United States. And what we ended up doing was taking down not only the mobile app, but taking down the entire website. And that was due to the fact that, nobody at that time had really thought through, the impact of the network. So latency, packet loss, jitter, and just all the characteristics of the network and how bringing your users up on mobile applications is going to impact, not only the network, but also the performance of everything else, including your data center, the streams coming in, et cetera. So, you're right. There's a number of different facets as you and I think about things like mobile and how you do performance testing or performance engineering around that. One of the experiences that I'm having right now in this video is, do I connect to this recording via the web client or do I go through the back client? And I think I went through the web client, but decided to go through the back client. And now I'm seeing very, very high CPU utilizations when I'm reading about 85% on my box. So much like that, how does that translate onto a mobile device? So we talked about the network. We've talked about other things that are running in the background. I know a whole other topic that maybe we could talk about, a little bit later is maybe, the impact of these libraries. So how much, actual coding goes on versus leveraging existing libraries. But what other stuff is running there in the background that we don't think about? Or if I call out to some third-party API, what is the impact of that? And I guess ultimately, what I'm seeing real time right now is what is the impact of that on that specific application? So, and then now thinking about the hardware that that's running on, this is another massive challenge that we run up against as it would relate to mobile testing is, what devices are you supporting? What versions are you supporting of that hardware? How about on the operating system? Like what versions of the operating system and how far back are you going to support? So, thinking about the specific application, the hardware that it's running on, the network, these are all elements that as we think about things like, this chaos that's being injected or performance engineering 2.0 or, whatever this, cliche thing is that we want to come up with. Again, there's a lot of different factors to think about around performance testing of mobile, but your experience in that ordering of, food and, how your body, they only test the top, what was it, 12 items or something, and they're all doing happy path. Awesome. How does that look with one user? Let's start with that, and then we can start cranking it up. But to your point, how many other items are there? How long are the sessions being held open? Unfortunately, there's things like cross-site scripting that we saw years ago, but now that you have these dynamic sessions that need to be held open longer, and they're because of mobile, and again, your typical just latency. If we just looked at latency on your typical LAN connection, you're probably like 30 milliseconds. Your average mobile one maybe like 300 milliseconds. So there's about a 10x difference there. Well, guess what? You're now holding these sessions open for that long period of time. So whether it's cross-site scripting, SQL injection, any of these very, very old things that we thought we had solved, well, we're now reintroducing that potential risk. So there's also a security element. And I guess if you're thinking about performance engineering, it's functional, it's performance, it's security, it's all of these elements wrapped into one to really understand not only just the application, not only just the hardware, not only the operating systems, but how does all of that work for my end user? And, oh, wait a second, now we're running on a cloud environment, or we have a hyper-converged infrastructure that we're running on, or we're moving from our legacy data centers up to some sort of off-prem cloud facility. Again, and downloading software. I just did something. Downloaded some software, and one download took 10 times longer than the other one. Well, why? Well, what was that back-end infrastructure that it was sitting on? So again, as we think about the complexity of mobile, it gets to be significant. And as we think about that spider web behind our device that's in our face, to okay, I'm thinking now to how many APIs or how many services, where are my data streams coming from, how much data resides, and then we can continue to talk about one of the awesome reports that when I was working for a large software vendor around this network virtualization piece, to be able to type in a URL, hit submit, wait about 5 minutes, and get this 20 to 25 page results report back, where we looked at 28 different performance characteristics of a mobile application. This was something that, again, who cares about, just one component, the network or just security, but I want to know, like, what is it that I need to do to fix my code? And, one of the very specific examples that we used was the header expiration dates. So long-term header expiration. Again, why is it that anybody would engineer into their mobile application, that every single time you loaded their app or you loaded their website on a mobile device, that you drive that entire workload to that device across the network, across the software, across the hardware, every single time? Like, really, is your code changing that frequently that you need to do it anytime that anybody loads your site? The answer is absolutely not. There's libraries that probably don't change, weekly, or maybe they don't change bi-weekly. So again, this was one of the things that looking at performance testing mobile, was just one of those really easy. And again, that's one of 28 different characteristics that we've looked at as far as, how to go in and optimize performance on a mobile device.
Yeah, and I'm going to give two extra things in there. The first one is around shifting right into the digital experience analytics space, right? So let me kind of explain a little bit what that is. First of all, we probably talked about digital experience before. To me, a digital experience is your entire round trip. So this is me speaking to Alexa, or actually I've just got a new AI robot called Vector, who looks at your face, does computer vision, recognizes it's you, and then lets you interact with it. But when I talk to Vector, it obviously, first it's using CV to understand my face. Second, it then logs into my account through the Wi-Fi, which it uses Alexa as the underlining API. It then goes through and does the request which I've asked it, do this, do that, set a timer, turn my lights on with my IoT. That all comes round. So that digital interaction is me talking to an AI assistant, a robot, and there's a whole round trip around there. And each time it passes off some information, because Alexa probably doesn't do the weather, AccuWeather does. Each time there's another third party getting involved and another chain. And what I find, what I talk about in shifting right in the digital experience analytics is we look at that life cycle as a full end-to-end, right? Now, we know if we're outside our data center, we're going to have a narrow focus. We can't measure what Stripe's doing from a payment gateway perspective. So we might be seeing everything coming back. Yeah, those APIs are all coming back, 40 milliseconds, looking great, right? But we're not managing the CDN for where all the content and images come in and how long that takes. We're not taking the Stripe payment data because we can't, because Stripe don't give us that information to say how long that payment took. So we're missing a whole stack of information as part of the digital experience analytics, right? And what I've seen, and you'll be in this zone very soon, is what people do is they do synthetic monitoring, right? So they do synthetic tests, which I think personally are worthless, because what they are is a headless version of a cut down REST API call, Happy Path, to say, is this API up? Here's a duff code. If it's Stripe, you set in an expiry date and do a phony kind of transaction. It either approves it or doesn't approve it. Tick, right? But that's not a real device, right? What it should be, and I just had Iran send me a message from Perfecto, and partly, it could be I need a physical device. And when I say a physical device, I mean a real phone that's connected to my digital experience analytics platform and is actually sending, doing that transaction on the phone, right? Or even more realistic is, and we did this 10 years ago, which is I want it on a 5G connection in downtown LA, which is where one of our outposts in, one in Detroit, one in Singapore, all with real devices, all coming in, creating the proper NFV and the network virtualization underneath it, to give me a realistic view that actually this is a phone connected to the underground network, and this is the kind of parameters. And yes, once you've got that NV profile, and I remember one of the companies you work for, one of the best apps I've ever used was on Android, where you could literally put a proxy on any app, launch that app up, and it would then start capturing information about it, right? And part of it is that's what you need to be able to do. Is you also need to be able to take something like I've got a Pi Zero in my hand here, which you probably won't see because the software is going to render it out. But sticking one of these in the different locations and then start profiling the network to see, well, what is that connecting through Wi-Fi in the underground, or using a 5G versus a 4G versus all this kind of stuff, and start injecting from real endpoints instead of kind of emulating everything, which is kind of where everything seems to be. The easy path seems to be I'll emulate something, whereas I think physical devices. And I think this is where, from a digital experience analytics perspective, we need real devices in real locations, in farms, that allow us to kind of get more realistic viewpoints of how our products are doing, not just synthetic tests. And by them being there and acting like real users, part of those bots' purpose is to start providing a digital twin. So this is kind of what I've been trying to talk quite a lot about, is how do you create a digital twin, and this isn't anything new. This backdates to, I think, 50 years ago when NASA went and did Apollo 13, and there was a problem. Houston, we've got a problem. You know, the first thing they did is built a digital twin of the exact same spaceship, and then they looked at all the bits which they could do in a kind of a dev prod kind of environment to find the fix that they could then deploy in the real world, right? So we need to start pulling down digital twins of our infrastructure and how our real environment is, and then start using those digital twins to run chaos engineering type scenarios where we can see what systemic failure looks like. Oh dear, swipe goes down. Okay, no problems. That means we'll go to a different payment gateway. We'll go to WorldPay, or we'll go to PayPal, or we'll go to, Sage. We don't care. We'll swap independently, and it can happen because it's already packaged into the mobile app, so it just switches automatically when it realizes there's a certain level of intelligence. And I think your question really, where they said about CPU and end devices, these edge devices are incredibly powerful. They've got ML built onto them. So why aren't we pushing some of that, hardware, some of that compute power to the actual phone? So, we talked about the example of checking only the top 15 products being searched. Why aren't we pushing it, creating a caching database on the local version of the phone, which it can search from when it's offline? What happens when it switches from offline? How can it continue running reduced sets of functionality whilst being offline and then re-handshaking afterwards? It knows you've got money in your bank. It knows you want to order bananas. So you say to your AI bot, order me some bananas. It doesn't say, I'm sorry, I can't connect to the internet right now. It says, okay, no problems. I'll do that for you. Or, instead of me queuing in 8 hours and 20 minutes and pressing my screen to keep it awake, because, that's the only way I can order food now, it just say, okay, I'll sit in that queue. I understand there's a basic rest, keep alive here going on. There's a cookie, there's some kind of credentials. When you're ready, I'll start doing the process. This was the whole point of what the next generation of internet was. And what we're seeing now is pretty much all the mistakes of our engineering limited view of what hasn't prepared us for this kind of problems. And that's the edge cases that no one ever thought of. They just thought, it's okay, we'll get it out quick, we'll get it out fast, we'll do continuous deployment, we'll be able to release 40 times a day. But what were they releasing? What was the quality? What was continuous quality? Where did it start? Where did the idea that actually we're going to build something, and someone has to make a decision of what we're building and what level of scale it can do, what the limitations are, what the product can and cannot do, and how it becomes part of a bigger ecosystem. Or if it doesn't, it just becomes like a Tesla. It's got its ability to just drive itself and not deal with car 2x and infrastructure 2x. It just makes the decisions based on the information it has. And I think that's what every company is at the moment, is they're not an organic digital ecosystem. They're literally a standalone, siloed product that sits on someone's data center in the cloud. And I think there's a lot of work that we need to do to kind of think about how we really take digital seriously.
It's interesting, and I think, Jonathan, as you and I have gone through our careers, what becomes even more interesting is the fact that when I ended up blowing up this online, or I guess it was a large bank, that was 2006. So that was 14 years ago. So at the fundamental level, what you and I are talking about, what you and I are experiencing right now, given the coronavirus outbreak and pandemic that we're dealing with, I mean, all of these things, even my children, like we're doing homeschooling now. So I have three children at home, plus I'm working at home. So, when you think about that and the impact that that's having on my local area network, and what does that mean to my service provider, in addition to they've got a third-party product that they have to use for all of their online learning. Well, it was interesting because in the first week of quarantine, what I started to see was, if you were trying to access that system during, like a 9 a.m. to 4 p.m. Eastern time here in the U.S., you were not able to get in. And, they kept saying, well, just go ahead and try later. And I was like, well, that's kind of funny because, how many users are going to try later? And they're like, well, no, this is off-peak time. And I was like, excuse me? I'm like, this is virtual learning now. You have all of these students that are now being asked to connect in, and you're saying off-peak. So again, I don't want to keep going back too much into these topics again, but the idea is, from a performance engineering perspective, the app that you had mentioned from that vendor that I had worked with or worked for, and we created that capability that it was an Android app. You could record, your specific end user connections and, et cetera, et cetera. There's so many things that are into this huge web, but again, we're seeing fairly unique, fairly different. I mean, this is, I remember when I whiteboarded it out probably in that same 2006 timeframe, was the idea of crowdsourcing and crowdsourcing for performance. Well, guess what? Coronavirus is now, the largest, unorganized, real-time performance test. And, you can now, through your metrics that you're capturing on the back end and all of the observability elements that you can see, again, how many users, what's their average length of connection. Most of the time you can capture what their network connection is out to the endpoint. So again, as we think about performance testing for mobile, as we think about the coronavirus pandemic that we're all living through right now, maybe another question to ask, and again, like I was a huge naysayer when the whole performance testing in production came out, because I was like, as soon as you impact your first user, which as soon as you let that new feature function out the door, you're potentially impacting negatively one user, not to mention what's that impact of that one user on everyone else. But what is it that organizations are doing right now to leverage all of those metrics, all of that data that you should be capturing? So again, you and I have often talked about, what are the appropriate coding practices? What are some of the frameworks maybe that you're using and adopting? Again, what's built into those networks and frameworks what are built into those frameworks to enable you to be able to capture these types of metrics in real time? Again, I know there's plenty of, vendors that are out there, having APM solutions that are capturing metrics like this. So you could be thinking about it from that perspective, or, what is it that we can pull out of Kubernetes using Prometheus, to get this type of data and then put it onto something like Grafana to visualize these metrics. Again, there's these real fundamental questions that, without having to get into, performance environments, performance data, performance tool, all of these other pieces. Awesome. Guess what? We're in a really unique time frame right now. What is it that you're doing to get access to those metrics, to see the actual results of what's going on, and see how your systems are performing, and ultimately being able to optimize them? Again, it's interesting times, but think about it. This data, especially if you're that vendor who's providing the service to enable education to our students, again, this is something that we need to figure out now. And again, we're sitting on, what is it? Sorry, it's the 12th of April, 2020, and I was just told that my children are not going back to school this school year. I'm looking at traveling for pleasure in August, and I'm being told that's now at risk. So again, what is it that we can do today to leverage, whether it's the metrics that we have, some of the observability capabilities that we have, but again, these are all of these, DevOps and SRE practices that if you're not already doing them, what are some of those that you could start to adopt today to make it easier for you to do better performance testing on mobile?
So, I can kind of jump in slightly here because I've just finished launching an app which is new into the App Store this week, which my team was responsible for building out. And so it was interesting that what you've just been saying, in the sense of we've just gone through that process, and it's really interesting because partly one of the things we learned was the app, which is just on the App Store, has been released on the App Store in April, so this month, is built on React Native. Okay, so for those who know React Native out there, what the great thing about React Native is it creates an iOS version and also an Android version, which is great. And so it shares the same code base, which is great. Facebook, created it. It seems like a really good idea, but it's still a separate team that are building a mobile app compared to the e-commerce website, right? That's just standard practice. And yes, maybe the website they're using, e-commerce website, they're using React.js, right? So everyone's happy. There's maybe a bit of reuse, but most likely there isn't, because the mobile app's different functionalities, subset of the full React.js library sets. So what did we do when we created this this mobile app? Well, the first thing we did is we did crowd testing, right? So we did use crowd testing, but what I found we needed to do by crowd testing was we needed to prove the app, right? And what we did is we looked at getting beacon data from the actual phone. Now, the problem was that, straight away, most people who use React Native will say, okay, we'll use Firebase messaging, which is just, for those who have used Google Analytics and Firebase pretty much do the same thing, but never shall the two meet, which that means when you're looking at your Google Analytics, you're looking at your e-com site, and then you end up using something like Snowflake as a database to actually take those two sources and then measure whatever those metrics are, cascading metrics are for your business, right? But again, mobile, Firebase, Google Analytics, e-commerce, right? So I'm in Firebase. I can push whatever information I can, but you can push very limited information. This user went to the login screen, but I want to know more. I want to know how long were they there for. How long were they, using that particular tile? How, what was the journey, what they did? And yes, of course, that telemetry data, some of that you can capture, but you have to enable it, right? Very much like if you're kind of doing Canary and stuff, you have to put in the code that there's going to be, if your user is flagged as VIP, then you're going to go down load this functionality, and if you're, depending on how you would do Canary or duck launching and stuff like that. But still, it's at a code level. So this was a bit too low level for us to scale, right? And I know you've done a lot with monitoring as code. So we actually went to an APM vendor and said, give us more information. And they said, okay, well, we've got an SDK, which is in private beta. We'll give you that and you can embed it into your app. So now I've got the APM, like you would do with the agent technology, which powers an APM, and you deploy that on all the nodes that you want to monitor. I've now got that same SDK packaged up onto my mobile app. Now, this shouldn't be in production, so you have to use something like TestFlight or an APJ file for Android. But I can use something like AWS Labs. I can use Perfecto. We talked about those. We can use the Microsoft. Have got a new platform called App Center, which allows you to manage this as well. So I push this out into my crowd, and then my crowd go through and do their journeys, and I get not only do I get their actions, which they're doing, and their information and their data, which I need to harvest. The second thing, what is really interesting to me, is I want to know what they're interacting with as far as the actual objects on the screen. And the reason why I'm doing this is because I can generate a model out of the back of it with the code for Appium. So what this allows me to do is a person does a journey, and I demonstrated this to the analyst community years ago when I was out in Silicon Valley, and what we did is I said to one of the analysts, go and use this app. We just launched it. He went through, clicked on a few things, registered, did a few different activities. And I said to him, have you finished? 30 seconds later, I'd generate a model with his data, the type of phone he was using, which was an Air device. And then I ran that same scenario with the data against the e-commerce website. And he went, how do you do that? That's black magic. And I said, no, that's just shift right and digital experience analytics. I'm just pulling the data from the model that you've just created and then generating the tests, which is easy. But you can't do that for a React Native app, i.e. a native mobile app, because you need the telemetry data built in to be able to give you an idea of what the widget or the class you're actually interacting with. So with this, I could create the Appium script. I could create the journey of what those crowd testers were doing. And I've gone a little bit too forwards, because actually at the start we used a product called wrong product there, but we used a product called InVision, which was a platform which is used by UX designers. And what that does is, when they're prototyping the look and feel of the application, it lets you create a deployable application. No code's been written here, so this is no code testing. They can create a flow of what they're suggesting the experience would be like. And you can deploy that to your crowd testers, and they could literally go, okay, I'll scroll down the app, I'll buy some eggs, I'll buy some butter, click on checkout. Wait a second, that doesn't look right. I need to put my address in, or I want to change my address or my credit card details. They can then give the feedback before even any code's been written on the journeys that you're doing. And you still create testable objects. You still create Appium scripts against that. You can create your UI scripts if you're using an e-commerce thing from a prototype, a wireframe prototype. So this is now really shifting left early to the point where there's no code ever being written, to when there's a real application and you've got millions of users sat there trying to log on to Google Classrooms, and you're trying to work out, well, what's the behavior they're doing? How long are they spending on a page? Are they getting stuck at a particular time in the curriculum on content subchapter 14? Everyone's sat and they can't get past that bit because it's just too hard or something, and they need some assistance in that point of view. All this analytic data, which is not being captured, to your answer, it's not being captured. The people who kind of talk about DevOps, which now has been replaced with platforms or infrastructure team, yes, they might have put the monitoring in, but they were monitoring in Prometheus and, Grafana, nice graphs of CPUs, which we know don't really represent anything really viable. It shows how that Kubernetes instance is working, and, how much they've wrongly sized the schema registry for, the configurations code. So they've wrongly configured MongoDB or Kafka or whatever to not perform with the right amount of consumers or producers, right? So that's what they're looking at. They're not looking at one level above digital experience. What is said student what's their experience looking like? How long is it doing till it's DOM ready? How long is it so they can interact with that interactable whiteboard? How long are they interacting with certain components till they load? Which is much more important, is the business components, which it translates into education, not the underlining KPIs, which are a pure measurement form, which is great for debugging, root cause analysis, pinpoint failure analysis, and to be able to understand from a stack trace perspective all the way down to crash analytics, what happened on a phone, and if you put null in as the username, it'll crash, right? But there's a lot more to this, and I think the data that we're capturing still too low level, and it's I think the next generation of intelligent APMs and AI ops, as the term unfortunately is being using, is going to start looking at putting that a level above to create a model, create a digital twin, and that digital twin can show you the behaviors of the students, regional, geo-based. Why are the kids in Detroit having real problems compared to the kids in New York? Oh, well, wait a second, they had an extra module in their final year. All this kind of data science and real cool stuff that we could be doing, we can't, because the right data is not there to capture, because all we're capturing is CPU cycles and garbage collection and all that kind of stuff. So I think there's a lot of stuff that we've got to think about. And we've also got, I think I started with that idea around test data. Not only do you need a model, but you need the data with it. And there's a recent podcast I did, there's only 20% of all possibilities in production. So by taking the historical view of the last 12 months or the last 2 days or the last 2 hours, you're still not exercising all the ETLs, the intents, transforms and loads, all the possible scenarios through your system, because users may only touch 6% of it that day or 14% of that another day. And it's only when coronavirus comes that everyone's panicking to try and switch where their shopping location is. So that's then starting to exercise that component mod. So we're starting to get a heat map of the dependencies of the code, which is impacted because actually it's using Google to go and look up where your GPX location is. And because Google's under too much load, it doesn't go to Bing GPX because it doesn't have systemic. It doesn't. No one's ever done any chaos engineering against it. So that's just a few things.
So it is interesting. One of my most recent prior employers, this was the large part. This was all of what I was responsible for a little over 2 years. Is everything that we've been speaking about as it would relate to things like AI ops, and specifically how is it that data is being generated everywhere today, and to your point, do we really care about the CPU low level utilization? Well, yes, we do, but I care about that as it would relate to what is that business transaction that my customer's doing, that my synthetic is doing, my load performance tool is doing, what is the security profile that's happening as the systems are being exercised, whether it's me generating them by a load tool or actual users or synthetic. So I guess as you look at all of those aspects and what needs to happen in related to things like digital twin, this is an area that is developing fairly quickly. There's probably one or two vendors out there that are trying to do it, but it's a lot of architecture. Looking under the covers, again, there's not a whole lot there. So again, my prior employer, we spent a lot of time. We had probably more access to resources than anybody else combined. So, we were very, very focused, though, on a very specific framework that, again, it wasn't 100% custom, but it was how is it that you take all of these different data elements, or what we used to call collectors. So we have a lot of collectors of information that are out there. You and I have already mentioned many of these. So how is it that you look at these as a data collector? So whether it be something like FluentD, or whether it be something like, name your favorite APM collector that has an agent that installs on a box. All of these things are collectors. So how do we kind of harvest that data? And again, what we were intending to do was to basically stream all of this data. So putting it on the Kafka, making it available to anybody and everyone right there at the collector level. Now, this would be before we would do anything from a correlation perspective, anything from a machine learning, artificial intelligence, predictive analytics. Literally, this is the raw machine data coming off of the collector and now made available to you by subscribing to a stream. So I think that's starting to happen fairly broad. But again, to your point, it's a very, very low level, metric that we're looking at that paints a picture, but it's a very incomplete picture. So what happened next is kind of in the middle area of our framework, which was all of that kind of engine piece. So again, this is where we did some of the machine learning, artificial intelligence, predictive analytics, ultimately moving to, the third view, which again, if we follow through, it's collector, it's data, and now this is where it's our end user, our end client. And again, it was funny because immediately our customers went to saying, well, I want to know, and this is, one of the CIOs in our business units, I want to know this dashboard must show this, I want to see my critical business flow, how many transactions are going through per second right now versus what were they doing yesterday or what were they doing an hour ago, but they wanted a dashboard. And that's immediately where everyone's mind goes. I think it still happens today. But you and I know that machines are consuming much of this data. Or, how is it that some of your major ticketing systems like ServiceNow, mentioned, them as a vendor, I think it's fairly prevalent. Or, you can look at other things like PeopleSoft. How is it that they would be interested in that type of the data? So now, after you've gone through this data piece and you now have your consumer, so collector, data, consumer, how is it that machines are going to be leveraging that? And, some of the things that we were able to do is one of my consumers and my CIO, she wanted to be able to ask her Alexa a question. How are my systems operating right now? And get an answer back. So, again, how is it that introducing that type of conversational through natural language, AI, you're able to harvest answers to these types of questions where, again, our CIO wanted to know across that portfolio of applications that she's responsible and accountable for, what is that state? Well, it's interesting because what is state? State equals critical business flows, infrastructure, application, customer experience, all of the bits that you and I have been talking about for a while now, and saying, yes, we need to roll all of that into one. So again, as we thought about this problem of creating a potential digital twin, so again, what are we doing in our pre-production environments to have the applications, be able to do the end-to-end flow, performance, security, functionality. How is it that we then introduce things like AI ops, which, I don't know if this is a topic for now, it's a topic for later perhaps, but I think what becomes very interesting in this, not from a philosophical conversation, but a very practical dialogue is, who is that is ultimately accountable and responsible for things like, it's not AI ops. AI ops is more the how, but, what you are responsible for is ensuring applications are up and running, infrastructure is up and running, customers are able to be served with those products and or services that you deliver as an organization. So again, thinking through everything we've spoken about, whether it's, this chaos concept, infrastructure as code, thinking about a pipeline, as you're doing the digital twin, I don't care what your CI/CD tool is that you're using, but how is it that you build this into your pipeline? And everything that we've talked about, whether it's, mobile performance and thinking about the network and the devices and everything else, if you know that, these 14 products are the ones that are most purchased on your site, and the customers are going to be logging in, they're going to be searching, they're going to be selecting, they're going to do some sort of purchase and or transaction, they're going to want to track it, they're going to want to see when it's delivered, you're going to want to get customer feedback from them. This is your normal customer journey. Awesome. Well, why is it that still today, that is not already pre-built into your CI/CD process with all of these quote-unquote stage gates, so that as these builds are happening, as your automated tests are running, you're able to harvest that data, again, not only from your lower environments, but also from production, to be able to get this picture that's coming back and saying, that is what you need to fix in your application. That's what you need to fix in your infrastructure, blah, 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 which, oh, by the way, that's still, legacy concepts and thinking, right? What is it that the machines are doing to tune and to optimize your applications, your infrastructure? And, to your point, you have a queuing platform on the front end of this, food ordering system. Well, interesting. Could we dynamically change that threshold? And, are there things that, we could serve up in a static nature where our customers know, yes, I can search for products, I can fill, up a cart in a very static nature. How often are item numbers, prices, blah, 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 how often is that changing? So again, are these things that, as you and I think about architectures and frameworks, that we could start dynamically changing, what site people go to? Again, not until you need to actually process a card, do you actually need to reach out to a third-party service and have a more dynamic experience? But again, have we already solved that? I don't think so. But these concepts of, A, who's responsible and accountable for chaos, for infrastructure as code, for pipeline management, again, is this the CIO of your line of business? Is this now, that in some organizations, again, your DevOps and your SRE teams have been deployed out into that line of business? Is that who's responsible for it? Is this a separate third party that you have, outsourced things to? So now, as part of your contract before you sign off. You need to be able to see these results. They need to have that stream that you can subscribe to, and that your SRE or your DevOps teams can just subscribe to that stream. You can see all the operational metrics. Now you can build that middle part, that data piece, to bring that stream in, now be able to map out, again, fully automated, what does that transaction flow look like that your customer is taking? So again, a lot of thoughts here. So who's responsible for that chaos in infrastructure as code in pipeline management today? How is it that things like digital twin and AI ops, which hopefully are just moving very, very fast in your organizations because the need is now. And this is more than just the low-level metrics, and it's definitely more than just the basic transactional flow bits. And, how is it that you're building this in via CI/CD, again, through all of your environments, again, getting those functional results, security results, and performance results fully automated. Again, this is something that every single build, it should be running. And what is it that from a regulatory perspective, a revenue perspective, or a customer perspective, you are or are not able to recreate in all of those environments. But again, think very small, very fast. Again, we want to run through these scenarios, fully automated, and use those as our stage gates before we, push into our later environments and into production.
Yeah, and I think, the interesting thing about that is, we talk about, that, the digital twin. We know the digital twin's going to change, right? We know, I remember when Alan Page said, what was the difference between how Microsoft tests and when he wrote the book, How Microsoft Tests and how things are today. And he said, well, the difference was we get in analytics pretty much in real time, in 2 to 3 hours, instead of waiting 2 to 3 days. Now, we know that's available, and we know companies that can, the APMs can give you that kind of insight, right? Whether it's, you're turning a corner on the latest Forza and the frame rates are dropping on your particular end device because the network's having problem or something else, right? It's got that kind of metrics already built in, Microsoft Operating Manager, MAMA, whatever, on the Xbox. Now, that focus kind of then comes back to, at what point does a digital twin in each one of those environments, so we talked about, it's important to deploy your APM in your staging, your production, your pre-prod, your learning environment that's learned from yesterday's transactions so that you can start hitting it, right, and do something, sexy to pull that information and shift right back to the start to prove the hypothesis by the model. I'm expecting these behaviors are actually happening, right? There's a question that we're asking, which is, is that, fit for purpose? Is it working? And also, where's the insight driven, the data driven insight coming from? So, a great example with the ServiceNow kind of aspect is, at what point does an AI pipeline, whatever tool, actually say to you, okay, your payment gateway is going to fail under this kind of load. We can fail forwards based on the code base that's in there. We can fail into this state, which allows us to go on to our secondary or tertiary providers. But, if that fails, we need some additional flags to be enabled or some code to be extended to try other providers. To a point where Service Desk get hold of it, and, your ServiceNow system prioritizes that based on business value, which is can't make payments. You may as well not be around because no one can complete your shopping. We bring that across, and then it's not thrown over to developers and the same people. The example of, if a builder does a really bad job, do you get him to redo your driveway, or do you go and find someone better to do it? Not allocate it to the person who wrote the code, but allocate it to the team that's actually responsible for SRE and solution architecture at a higher level, and kind of makes a decision of how important this is and how much work needs to be done. And then you fix that, and it's working with operations, not just development. At the same time, when you're doing your idealization, why isn't ops involved? Not just your SRE teams, but your ops teams actually understanding what the end state should look like and what are those metrics of success in there. So, I saw a good keynote the other week which literally said, just because REST is a great solution. You shouldn't choose the same architecture because everyone else is doing it. We'll go serverless. We'll do this just because they get to play with the latest tech. And then you come and do a JSON payload, which is 14 meg with a whole stack of data. And then the easy solution is, we'll just make it smaller. We'll send out 14,000 of these transactions. You're thinking, wait a second, when did we decide that a lot of these architectural decisions are just because, the latest modern architecture technology decisions, what everybody else is doing, are fit for everybody else? So, part of it is I think we've got to come back to this kind of enterprise grade aspect. The idea when, Tibco or something like that, having a messaging bus that didn't matter what happened, you could shut your entire company down for a few days, come back up, and all the messages will still be there and they'll get processed, right? What is the quaz behind things that actually make sure that when you hit that REST API, that comes back with a timeout error, it's not handled, doesn't get posted on the Kafka messaging, so it's not secure, it doesn't actually get through, and the end user just gets a weird message saying cannot process, or not even gets a message, and they don't know if the order's done or not done. And then to your second point, we talked about this idea of using edge devices a little bit more, using them to have the database cache. Does stock really change that much in pricing? And if it does, that can be changed, at checkout. Oh, by the way, milk's gone up 2 pence. Sorry, are you happy to accept this change? Yes. Do we really need that same experience of buying stuff when we can do that generically? I talked in the TED talk behind about in Korea about the fact that you can literally order your supermarket on a screen on the underground, and then there's no actual shop. You just scan that item. I want some bread. It's got a SKU. Who cares what the SKU resolves to and which provider provides the milk? It's just a GraphDB, which then does a GraphQL to say, give me this user wanted milk, semi-skinned. Who's got that in their stock? Okay, you're the best part. You've got a what we would have classed as a commodity trading platform that will buy it and source it from who's available at time. I think the fundamental architecture of how we've created things, and we called them as a service. They're not really as a service. We've just created our service and put it in the cloud, and there's no collaboration. There's no open standards. There's no okay, yes, my payment gateway, let's call it WorldPay for a second, gives me, like you just said, all the Kafka information that I need in metrics that I understand into my multi-transactional data transaction format, which gives me that ODB, data format that gives me a view that I can do the kind of the processing, the time series data. So if you've got something in influx, and I'd recommend the tick stack just as a quick way to get up and running with this stuff. You say to them, that's the kind of data that I want. You provide us that information, and then you can, from an APM view, get hold of that information and start doing pure paths across, different service providers. You can start getting the data that you need, and it's not just a fire off and forget. I think this is where we've got to be more, we've got to think about our solutions again and really come back to architecture. The idea of, solution architects actually being there in teams and above teams, and those enterprise architects, that's disappeared. Each team's now responsible for delivering, capability A, and they don't speak to all the other teams about whether or not capability A is the right way to go with this stack. And then what you get is a whole stack of other stacks that they say, it's fine, we'll just all stick it onto Kubernetes, it'll be fine, and it'll all interact with each other because we'll just then create some more REST APIs to talk between each other, and some more Kafka messages. We'll just stack more stuff onto that. It'll be all fine until it's not, and then we're in this situation now where we're looking, have we engineered any of these systems to be able to deal with the kind of capacities we're doing? And you said about, home, I've got, and maybe it's a bit over the top, but I've got, a proper network switch. So, it's doing quaz, right? I've got no Cisco engineering skills, but I've got separate VLANs because I want to be able to isolate my bandwidth and prioritize what's over there, so I don't want Disney Plus to be taking my bandwidth. And I need to also, because I've got lots of IoT devices, I'm also hitting the limit on those on my mesh. So even though I've got 4 WAN devices, I'm having to introduce this stuff because I still need to make sure you can do a video call. You can prioritize what's important. I could I'm sure both of us could run a performance test now and just eat all of our bandwidth, but also denial of service attack, an endpoint very quick, like an IoT cannon would do, right? Hitting something too hard doesn't prove anything. And like you said with login, we expect that login, these transactions happen, but should it? Should you need to log in? Why haven't you just downloading a certificate that expires after a week or something, and therefore log in and your LDAP servers don't get absolutely pounded? You've certified, you've got a secure connection on the device, use iron thingy if you need to, but you make it so you don't have to log in, so you don't have this traffic of everyone going through this, AORth kind of 2 approach to getting, their tokens.
But what's interesting, Jonathan, in that very specific example, because what you and I are talking about is often handled as a service. Sometimes it's handled as a third-party service. So, there's 2 things. So one, it could even be as simple as, you're dropping a background or a CSS or something, whatever that, maybe it's just a JPEG or an image of some sort. Every single time anybody comes to your login page, you're sending that login, icon button. Well, okay, how often have you changed that login button? Like, not even thinking about that password service itself, but just that button. Like, I get it. Maybe it's only a 5K, 6K file, but how many of those types of things are on that one page? And, if you're serving somebody up who's in downtown London, and you know it just as well as I do, London, New York, San Fran, you're often getting bumped onto like a 2.5G edge connection, maybe into a bad 3G connection just because of the nature of the beast. Well, what does that mean when, now I have, 20 6 to 10K files that I'm trying to push over that type of a connection? So what I wanted to say is it's a much, much more simple and less complex potentially problem that we observed through those tests that we were doing. And again, that's one of like 28 different factors that we looked at. But, your point is extremely valid. And I remember sitting on dial-up saying, it's going to be so much better, when we get more bandwidth. And all the hype over the last however many years now, 5G is coming. Well, when 5G is here, it's going to solve all of our problems. Guess what? For some reason, we tend to build, applications that take more bandwidth. Or, you mentioned, having streaming available. You mentioned having, all of this other data that's available to us now. Or, I want to put some SDK out there and be able to put a little hook behind the scenes. And, these are all things that you and I knowingly, yep, okay, I'm going to put that in there. It's going to be my alpha release that's going out to my, jungle testers, and I want to get these types of results while we're still in an alpha or a beta, and see what's actually going on. But you knowingly are increasing the payload of that application to that, end client device. Okay. The other piece that you started mentioning, and I'm sorry, I know I kind of stepped in with a comment and it's going a little longer, but it was funny. I remembered reading a blog post this past week that was an announcement from Uber. You may have also seen the same one, but it's directly in vein with this, and I'll send the link around so that maybe we can include it. But it's interesting because the headline was, one team at Uber is moving from microservices to macro services. And so again, you and I talk about these, what's the latest tech trend, what's the, everything that's going on. But it was very interesting that even in that headline, it says not a monolith. So it has no more than 20 developers or 3 teams working together, and again, but I'm like, right. So we've created this massive microservices driven architectures, and for what reasons and why. And we've also talked through the complexities that we introduce as a result. Again, how is it that from a performance, security, functional, and again, you look at these massively microserviced pages and big online shopping. Well, a customer is not going to care if the number of stars, or the number of reviewers, if that one little feature is not working on the page, they're not going to care.
But if you care, why don't you join us on the next podcast? I've had to limit this one to an hour, just to give you a bit of a teaser on some of the topics we're going to discuss in the next couple of weeks. So that was Todd DeCapua. He's our Chief Technology Evangelist. You're listening to Vivek Talks, and stay tuned for the next exciting episode on performance engineering. And yeah, if you need to contact us, you can send myself or Todd an email at jonathan@coronavirus.fo, or you can contact me via the vivekworldwide.org website. Keep safe and stay at home.